Hello, and welcome to the Migrating Your iOS and Android SDK to Next Gen webinar. My name is Luke, and I'm joined by my colleagues Dane, Director of Engineering, and Jens, Senior Software Engineer at Yubico. Before we dive into the presentation, I'd like to cover several housekeeping items. If you have a question at any time during this webinar, please use the Ask a Question tab located below the player. Your question will be addressed during our Q&A session at the end of the presentation. If you have any technical difficulties, click Support for Viewers at the bottom of the page for troubleshooting help. And finally, please take a moment to rate this webinar at the end of the presentation. We'd like to hear your feedback using the Rate This tab. And a recorded version of this presentation will be available using the same URL shortly following the conclusion, so you can replay or share with your colleagues. So today, the team and I will be giving some tips and tricks on how to upgrade your existing Yubico Mobile SDK apps to use the latest version of the SDK. We'll cover some of the structural and terminology changes, new ways to discover devices, how to monitor connections using callbacks and delegates, and a brief introduction of the PIV support on the iOS SDK. And I'll quickly go over some of the high-level use cases where we see partners and customers using the SDK. Dane will dive into the Android parts and Jens to the iOS specifics. So let's get started. So we're seeing that users are expecting more mobility and access to their resources at any time from anywhere while demanding greater security and trust. Enterprises see strong identity authentication as a critical part of their zero trust network architectures. National ID schemes that support strong authentication are increasing in number, visibility, and reach. And YubiKeys offer multiple authentication protocols and are uniquely positioned to help individuals and organizations protect their identities as they make progress on their journey towards strong authentication everywhere. In order to do their work, users may have to log into an ecosystem of products and services with various authentication assurance levels. They may have a VPN, which requires a one-time passcode, and a web application, which offers strong authentication with WebAuthn and FIDO2. YubiKeys allow these users to easily move between on-prem or cloud services, even between devices such as laptops or mobile phones, with a single key that gives them the security of a hardware-backed multi-factor authentication experience everywhere. And this is where the Yubico Mobile SDK comes in. It gives Android and iOS app developers access to the full functionality of the YubiKey. And now I'll hand it over for Dane to go over migrating to the latest version of the Android SDK.
All right, thanks, Luke. So the new version is 2.0, and this is going to be talking about some of the differences between 1.0 that are new. And we will start with the modules. So the Android SDK comprises several different modules. You can depend on those modules that you actually need in your project, and you don't actually need to pull everything in. So between 1.0 and 2.0, some of these have been renamed or restructured, as you can see in this table. First up there, we have the YubiKit module that we had in 1.0 that used to sit at the center of everything. It contained common classes that were used by the other modules, as well as the Android-specific low-level device communication code. So we've taken this module and we split it up into two. There's the core module, which has the common classes and interfaces that are used throughout the SDK by the other modules. And there's the new Android module, which contains all the Android-specific implementation. The core module gets automatically pulled in as a dependency if you use any of the other modules. So pretty much all you have to do is, if you had a dependency on the YubiKit module, change that to depend on the Android module. Next up, we have the OTP module. So that contained an OTP activity, which was this dialog used to ask the user for an OTP from their YubiKey. We've moved this class into the Android module, And it's also been made more generic so that it can be used as a general purpose dialog to ask your user to interact with the YubiKey. So inserting a YubiKey and performing some operation. Other than that, there wasn't anything really in the OTP module, so the old module has been removed. And next up, we have the MGMT module. So the old one did two different things. It handled device management, but also configuration of the OTP, the Yubico OTP slots on the YubiKey, and providing programmatic usage of the slot-based challenge response credentials. We've split this up into a management module for device management and a YubiOTP module, which handles everything related to the OTP slots. So here's an example of what a build Gradle configuration might look like. So as you can see, not much has changed. If you have the old version here up top, where we've replaced the YubiKit module with the Android module, and the MGMT module there has been replaced with the management module. Up next, we've changed a bit on how you do device discovery. We'll talk about both USB and NFC, but we'll start with USB. So this is the old way. Same as before, you use the YubiKit manager object to do the device discovery. So that hasn't changed. To start listening for YubiKeys over USB, you still call the start USB discovery method, and you pass it some configuration, and this again hasn't changed. So what has changed is this USB session listener interface that's used here. So as you can see here, the old version had these three different methods that you needed to implement: on session received, on session removed, and on request permission result. These were called when a YubiKey was attached, removed, or when permissions were granted. And actually, if you use the default configuration, the request permissions result function was never invoked, because the default is that the SDK takes care of permissions for you. So on session received gets called once you actually have permission to use a YubiKey. So the new way in 2.0 initially looks the same. You do start USB discovery. Now we've replaced the USB session listener with a more generic callback interface, which is used in various different locations in the SDK as well. So that has a single method, and checking permissions or handling the USB unplug event can now be done for the specific YubiKey device reference that you get. So instead of having a separate handler for that, you get the device, you can check if it has permission or not. And again, by default, you won't have to do that. You can just assume that you have the permission. And you can add a set on closed handler to do something when the device is unplugged. So because this new interface only has a single method, you can replace it with a lambda, and you get rid of some of that boilerplate code. Moving on to NFC, it's a very similar change, but the difference is a bit more subtle. So again, we've replaced the old NFC session listener interface with a more generic callback. The two NFC exceptions that you can see that can be thrown there have also been merged into a single one, where you can check on that exception if the error is due to NFC not being available on that phone, or if it's just disabled. So in that previous example that we showed there, you see how to connect to a YubiKey. And what we ended up with in those callbacks was called a session in YubiKit 1.0. We've renamed that to device in 2.0. And this better matches the standard Android naming convention where you have classes like USB device or Bluetooth device, and it's a reference to a YubiKey, but it's not an open connection that can be used to actually transmit data. We've also renamed what we in 1.0 called an application class. So the notion of an application still exists, but as a concept that lives within the YubiKey. So for instance, you have an Oath application and a PIV application. Those are running on the YubiKey. So in the SDK, you have an Oath session or a PIV session, which is an open session to the YubiKey talking to that application. There's more detail about this on the link that I've got here. You can also find that linked from our GitHub. So next up, that brings us to actually opening these connections to be able to communicate with the YubiKey. So by its very nature, the YubiKey is a single threaded device. You can only have one application active on the YubiKey itself at a time, and only one connection can then be used in parallel. And if you attempt to use a connection between multiple threads in the SDK, then you're likely to end up with a bad state, and you're going to run into strange problems and errors. So because of this, we in the past recommended that you open and use connections in a specific worker thread. So for example, you can use a standard executor service and make sure that anything you actually do with those connections is executed in that executor service. And that's what that example shows here. So the whole block is run in the executor thread. It opens the connection, and then you can run commands against it, and you, at the end of this try-catch block, that connection is closed. So in YubiKit 2.0, we take care of the worker thread for you. And instead of synchronously opening a new connection when you call open connection, we now do it asynchronously through a request connection method. And this takes care of internal queuing. So you can call that from any thread. You don't have to worry about if you're on the main thread or something else. And it will then queue up the request and invoke that callback handler once the request is open. And it will do that in a separate thread. So you'll be in that worker thread when that gets invoked. And again, we're using the same callback interface as we looked at before. Another thing that we've done here is that we close the connection automatically once this block completes. So there's no risk of forgetting that, leaving the connection open. Because opening a connection might fail, the result that we get here contains either the connection on success or an exception if that failed. So you still get to do that error checking in this block. We've also renamed the ISO 7816 connection class to smart card connection, which is a bit more user friendly and just easier to say as well. So these are, of course, just some of the changes that we made. But if you've been previously using the 1.0 version of the SDK, then we think this is a good starting point for upgrading, and hopefully this will help you migrate to 2.0. And of course, everything that I've covered today is also available in our GitHub repository. There's a link right here. And there's also a bunch of new features which you can discover by looking at our GitHub page as well, like much more advanced Yubico OTP slot configurations, more advanced PIV support. Just check out the project page for all additional information on that. Thanks. That was it for me. Over to Jens.
Okay. Thank you, Dane. I will walk you through the changes in the new iOS SDK, and I'll share some tips on how you might migrate your app to the updated version. So we'll start by looking at some renaming and alignment changes that we made to the iOS SDK. And you'll recognize some of these from Dane's talk. So sessions that we used to have in the old YubiKey were really just a pipe where you were sending commands and data and retrieving stuff. So they were not really sessions. So we've renamed them to connections. So now we have, instead of YKF accessory session, we have YKF accessory connection, which is more what it is. It's basically just the raw connection between the SDK and the YubiKey. We've also changed the name of our YKF OAuth service to YKF OAuth session. And the reasoning behind this is that this service actually held quite a lot of state. And as such, it made more sense to rename it to a session. And as Dane said previously, the session maps to a selected application on the YubiKey in the same way as the Android SDK does. Next big change is how we monitor the connection status of the SDK. Previously, this was done with KeyValue Observation, and it was kind of tricky to implement this, especially in Swift. So we've changed this to a simple delegate protocol to align better with how Apple do this in their more modern APIs. And it should be a lot more familiar with Swift developers, and also a lot easier to implement support for this. This delegate protocol is very similar to how Apple's Bluetooth protocol, for example, works. So we have a bunch of delegate methods that get called once a connection appears or disconnects. So for example, the did connect NFC method will get called on the delegate as soon as a NFC connection appears. And similarly, the disconnect NFC method will be called as soon as that NFC connection is disconnected. And if that was caused by an error, you will also get a additional error. So this is a sample implementation of the YKF Manager Delegate protocol. So we got two variables, accessory connection and NFC connection. These are optional variables, so they either have an accessory connection or they're nil if there is no accessory connection. And the same goes for the NFC connection. So basically, as soon as one of these methods gets called, the connect method, so if did connect NFC gets called, we just set the NFC connection variable to that supplied connection. And if it did disconnects, we just set the NFC connection to nil. So in this very simple sample, we don't do any error handling or anything like that, but it should give you a good idea on how to implement the protocol. Also, it's important to not forget to set the delegate on the YubiKit manager to your class. If you forget that, none of these methods will get called. So that's pretty important. So this is pretty neat tip for easier management of your connections. So this is just added to the previous class that we had on the previous slide. So it has a connection callback, this first variable, and it returns, or it calls a connection with a YKF connection protocol. Both the NFC connection and the accessory connection implement this protocol. So this connection callback will either give you a NFC connection or a accessory connection. And then we have the important part of this trick is the connection method here. You basically call it with a completion block that will get called immediately if there is a accessory connection. And if there is no accessory connection, we will start the NFC scanning. And once a NFC YubiKey is connected, we will return that. So let's take a look at how to use this stuff. So you create your YubiKey connection object, and then you call connection on this YubiKey connection, the connection method. And it will take a completion block. And since it's the last parameter in this method, it's we can do this trick with Swift with just this trailing completion. So we call the connection, and then a few minutes later or immediately, depends if there is a accessory key or not connected, we will get a connection. And as I said previously, that could either be the NFC connection or the accessory connection. And once I have the connection, I can get a FIDO2 session, for example. And I also get any errors that might happen when I try to get that FIDO2 session. And once I have the session, I could call methods provided by that session. For example, reset in this case, which will reset the FIDO2 application on the YubiKey. Another part of the SDK that has seen big changes is the move from services to sessions. We not only changed the name of our sessions in our services into sessions, we've also changed the behavior of these. So previously, the services didn't actually select the corresponding application on the YubiKey once you retrieved your service. And the services also supported, kind of at least, multiple services, or multiple. You could have a management session and a auth session service at the same time. And the SDK would kind of try to select the correct application on the YubiKey, and it will try to handle the different states. And you could actually call execute commands on the management session, and then switch to the auth session, and then go back to the management session. And this would kind of work magically most of the time. Problem is that it's super hard to do this, and it could lead to unexpected behavior, which were really hard to debug. So the 4.0 SDK don't support multiple active sessions. So as soon as you retrieve your second session, we will actually invalidate the previous session. And if you try to run any commands on that previous session, you would get an error. Since the sessions that you get from the SDK now actually have a selected application on the YubiKey, we need to make that call asynchronous. So instead of just getting the variable from the connection, you have to call a FIDO2 session in this case with a completion block that would give you the session or an error if something goes wrong. So it's now an asynchronous call instead of just fetching the variable from the connection. We've also removed a lot of unnecessary request and response objects. These objects were used at pretty much every single command sent to the YubiKey. Sometimes they held on to a single variable, as in this sample that we're looking at here. And in some cases, not even that. So you just created a empty request, and then you executed that request on your service, and then you got a response. The same goes for the response objects. Sometimes they contain credentials, as in this case. Sometimes they were empty. So we've basically removed all the requests that you could easily implement by just passing the parameters with the method call on the session. So in this sample code here, instead of creating a request with a timestamp, we just call list credentials and pass the timestamp there. And instead of getting a response object where we get the credentials out of the response object, basically just a wrapper around an array of credentials, we just get the credentials returned from list credentials, or an error if something goes wrong. So this makes working with the SDK a lot easier and removes a lot of unnecessary code. It also makes the SDK a lot easier to develop. So it's a win for everyone involved in this. So if your application depends heavily on KeyValue Observation, since we've removed that, it might be difficult for you to just switch your KVO stuff to a delegate pattern like this. You could actually do something similar to this sample here, where you implement a wrapper, a KeyValue Observation wrapper that contains two dynamic Objective-C variables, which is a accessory connection and an NFC connection in this case. And with this YubiKit KVO wrapper, you can easily observe any changes to these two variables, just like you did in the old SDK. So if you just want to get the new SDK in place quickly, you could just do something similar to this and keep using KVO for monitoring changes to the connection. So besides the changes to the SDK, we've also implemented support for PIV. So it's pretty much feature parity with the Android SDK. And this sample will show you how to store a private key in the PIV application on your YubiKey. So we're basically just creating a key pair, and then we save the key on the key using put key, and then we also supply the slot that we want to save this key in. So we're really looking forward to see what people could use the PIV support for. And finally, we've also rewritten all of the full stack tests in the SDK. And these new tests are actually a really good source of sample code, and you can find them on this URL. And I think especially the PIV tests are very good samples on how you could use the built-in crypto libraries in iOS together with the PIV module in the iOS SDK. So yeah, that's my last slide. So I'll hand it back to Luke. Thank you very much.
Thank you, Jens and Dane. That was a great overview. If any of you have used the Yubico Mobile SDK before, hopefully you've found this information helpful and like some of the major improvements to help streamline your development that have been outlined here. I'm excited for PIV on iOS and how the connections have changed for asynchronous communication. I thought that's really great. So let's go to the questions. All right, first question. If you have any questions, like if I have any questions or I run into any issues during my migration, where can I go for help? Dane or Jens, you want to take that?
Yeah, sure, I can take that. So if you have any questions or need support, the first step is to go to the GitHub page and file a issue report. Yeah.
Yes, and we also have support tickets. So if you'd rather go through that, path that's available to you as well. And if you're looking for something more hands-on, more white glove, Yubico does offer professional services, so you can contact Yubico to learn more about that. Cool. All right. We got another question. Are there any concerns if I continue to use the existing, the old SDK and not upgrade to the next gen SDK? Jens.
No, there shouldn't be any issues with that. These are the changes that we made are improvements to make the SDKs easier to use. There are no security fixes in these new SDKs.
All right. That's good to hear. And it looks like this is the last question. Does Yubico have any plans for a desktop SDK or platform that's similar to the mobile SDKs?
Well, it is roadmaps, but we can't share anything as of now.
All right. So sign up for the developer program mailing list. I'm sure we'll be looking for announcements for whenever that comes out. All right. I'd like to thank Dane and Jens, and we'll end the presentation here.